So up until now, we have been using the map, filter, and reduce methods kind of in isolation. However, we can take this one step further by chaining all these methods one after another. For example, let's say that we wanted to take all the movement deposits, then convert them from euros to dollars, and finally add them all up, so that we know exactly how much was deposited into the account in US dollars. Okay? Now, we could of course do each of these operations individually and store each result in a new variable. However, we can also do it all in one go. So let's do that. And I will start here with the filter method. So as I said, we want to take all of the deposits. So we get the movement here, and then we filter only for movements that are positive. And so only these are the deposits. And so the result of this operation here will be a new array. And so now we can call map on that array. So here again, we then get a movement. And now we can convert that movement to US dollars. So we can do that with that variable that we used before. Let's see where that is. So euro to USD. So movements times euro to USD. And so with this, we converted all of the deposits to US dollars. But now we can take this even further, and on this result, we can also call a reduce. And of course, we could also call more filters or more maps. But now let's just do a reduce here. And so basically add all of these values together. And so we already know how that works. So accumulator, and then the current movement. And we just need to return accumulator plus the current movement. So that's movement and 0. And so now let's store all of this into total deposits in US dollar. Okay, so you see that we did 3 data transformations here all in one go. So let's log it to the console to see that we actually get a result here. And yeah, we do. So this is the deposits that we did into our account in US dollars. And as I mentioned, we could of course change many other methods here as well, as long as they return new arrays. So filter returns a new array, so we could have added something else here, or the same goes for map. But reduce, for example, will return a value, so only this number in this case. And so of course here we could now not have chained a map or a filter after this. So we can only chain a method after another one if the first one returns an array. So you can imagine all of this as a sort of pipeline that processes our data. So we put data in at the beginning, which is here, and then it goes through all these steps. So in this case, these 3 steps here, and then in the end, our input data comes out processed on the other side of the pipeline. So let's just write this here, because I think this is a nice analogy, right? Now, when we chain all these methods together here, it can be a little bit hard to debug if one of the results is not what we expect. For example, if this result here would be something really weird, we wouldn't really know from which step of this pipeline it would come from, right? And to solve this, it would be good to check out the array in each of these different steps. So let's say we did a mistake here and we wrote it like this. And so our result would come out negative, and that would be strange. So in this case, it would probably be like to know the result of this filter operation. And so we can do that by using the array parameter that we get access to in this callback function. Remember? So we have the current element, the index, and the entire array. And actually, let's duplicate this here first. Okay, and set this back to what it was. Okay, so let's now log to the console this array. And so now we need these curly braces because we will have a code block, and we need to actually return our calculation here. But anyway, we can now take a look at the whole current array that this map method here is being called on. So let's take a look. And so indeed, it is this array of the 3 negative movements. So let's log the movements here one more time. So you see that indeed we get these 3 negative movements now. And so that is the result of this filter here. And so again, if we want to see that result of only this operation, we can check out the current array in the next array method that is chained on that filter. And so in this case, it's the map. And so this is one of the great use cases of having access to this current array. Because as you see, of course, this array has to be the result of the previous operation, so of this filter. It is not this initial movements array, because that's not what we called the map method on, right? The map method was called on the result of movements.filter. And therefore, that is the value here of this array. That makes sense? Now it was of course logged here 3 times because this callback function here is called 3 times. So once for each of these 3 values. Okay, so let's put it back to what it was. And now we get the correct array. And this one is now printed 5 times because there are 5 values in the array. So let's just turn this one off here as well. And so this was just to show you that we can inspect the current array at any stage of the pipeline using the 3rd parameter of the callback function. All right, and so now that we know how this chaining works, we can go back to our application here. Let's give us some more space. And we can now calculate these statistics down here. So that's all of the deposits. So incomes here basically. Then we have the outcomes. So that's the sum of all the withdrawals. And then also an interest that the bank might pay us. And so let's go back up here to the application. And so we already have display movements, calc display balance. And now here I will create another function called calc display summary. And just as our previous function here to calculate the balance, this one also receives the movements data. And so we will also call it with the account1.movements. And once again, we will then later change this to the user that is logging into the application. Okay, so let's start by calculating the incomes. So that's this first value here. And so that's all the movements. And then we filter them for only the positive ones. And so this is now exactly what we did before. So greater than 0. And now onto this one, we simply chain another reduce. Because now we want to add all these positive numbers together. So there's no mapping involved here. It's just filtering and then adding together. Give it a save, and now we can put it here inside of this label. So this HTML element. So it's always a good idea to check out the name of it. So this one is called summary value in. So as before, I already have that here. So it's this one, and it's called label sum in. We will also then need label sum out and label sum interest. So keep these in mind for a bit later. So here we have label sum in, and then our old text content property. So in comes, and then the euro sign. And now I know how it works. At least on Mac, you can use the emoji picker. And then you just search for euro, like this. And here you go. And I'm sure there is something similar on Windows as well. Let me actually copy it and put it also here instead of this euro. And the same also here in this movement. So here where we display all the movements so that the euro sign also appears here on all these. Okay, this should now already be working. So let's give it a save. But nothing happened here. That's because I am calling the wrong function here. So this has got to be summary. So I was calling calc display balance for a second time. Now it works. So that's 5,000 euros. And you see that also now here we have the euro sign, which makes it look a little bit more like a bank application, right? And now here the same for the outgoing money. So we're going to calculate a variable called out. And now I want to leave this one here again as a challenge for you. So that's a very simple one. Just don't look at the rest of the code. And I'm sure you can do this one without any problem. So that's just movements dot filter. And so now it's basically just the opposite. So the negative movements. Okay, and then label sum out, set to out, and that did not work. I see we have an error here, and so assignment to constant variable. Now, I see we are forgetting here the text content property. Maybe you saw that coming. And now it works here beautifully. Okay, now I just want to get rid of this minus sign here. We already know that the money is going out, so there's no need for the negative sign. So let's just take the absolute value here. So we did that before. So math.abs, and this is going to remove the sign. Yeah, beautiful. Now finally the interest here. And so let's say that this bank pays out an interest each time that there is a deposit to the bank account. And that interest is 1.2% of the deposited amount. Unfortunately, in the real world, it's nothing like that. But here in our fictional bank, we can do whatever rules we want, right? So as I said, the interest is paid on each deposit. So first, we need to get these deposits. And so that's this filter here. We just copy it. Okay. And so now on each of these deposits, we will receive 1.2%. So what do we do here? Well, we're going to create a new array which contains all of these interests. And then in the end, we can just add them together. And so map is the way to go here. So we take the current movement, and we could even call this here a deposit. Let's do that. We know that this has to be a deposit, and so let's call it that to make it a bit more explicit. We could do the same here, but that's not necessary. So we get 1.2%. So we multiply this by 1.2 divided by 100. So that's how you calculate percentages. And then finally, we just add it all together. So let's just take this one here, chain it here. And now each of the current elements is no longer a movement. So let me just call it here an interest, so int. All right. And now let's also just copy this one here. So label some interest. And then here, of course, it is the interest. And you see, we got 60 euros of interest. Great. But now let's say that the bank introduces a new rule. So now the bank only pays an interest if that interest is at least €1 or whatever other currency. So where do we put that in our calculation? So again, only if one interest is at least 1, only then it will be added here to this total. And so this sounds like it's got to be somewhere between this place where we actually calculate the individual interests and here where we then add them together. So let's add a new method here in the chain between the map and the reduce. And it is going to be a filter, because we basically want to exclude the interests that are below 1. So this one here is an array of interests. And actually, let's take a look also at the current array here. So interests, then I, which we're not going to need, and the whole array. And so let's log to the console the whole array just to see what's happening. But anyway, what we will have to do here is to filter the result of calling these interests here for values that are at least 1. So interests greater or equal 1. And only these interests will make it into the final calculation. So into the next step here of the pipeline, which is this reduce. So you see that the interest now decreased a little bit. And that's because indeed here in this array of interests, we have one value that is below 1. So this 0.84. And therefore, it will get filtered out in this new step that we edited here to the processing. And so then the final interest that's going to be paid by the bank is only these other 4 values added together. So these 3 plus this one. But this one here has been excluded. All right, that makes sense. So anyway, this was another great part here of our Bankist application. So with this, we now also completed this part here. And hopefully you can start to really appreciate the huge advantage that working with these array methods gives us over simply working with more traditional loops. And now just to finish this lecture, let me just give you a couple of remarks about chaining. So first, we should not overuse chaining. So we should try to optimize it, because chaining tons of methods one after the other can cause real performance issues if we have really huge arrays. So if we have a huge chain of methods chained one after the other, we should try to compress all the functionality that they do into as little methods as possible. For example, sometimes we create way more map methods than we actually need, where we could just do it all in just one map call. So when you chain methods like this, keep looking for opportunities of keeping up your code's performance. And second, it is a bad practice in JavaScript to chain methods that mutate the underlying original array. And an example of that is the splice method. So again, you should not chain a method like the splice or the reverse method. I mean, you can do that, and for a small application like this one, it's not a big deal and it's not going to cause problems. But in a large-scale application, it's usually always a good practice to avoid mutating arrays. And we will come back to this when we talk a little bit more about functional programming. Anyway, with that being said, there is now another coding challenge waiting for you.